Vinod Nair's podcast.
Have you ever just looked at a simple pill and really thought about the incredible, totally unseen journey it took to you? Well, today we're going to pull back the curtain and explore this invisible fortress, this massive, complex system of rules, technology, and people all working for one single mission: to make sure every medicine you take is perfectly safe and effective. So, let me ask you, what do you think is the number one biggest threat inside one of these places? A big chemical spill, maybe? Some catastrophic machine breakdown? The real answer? Well, it's something way, way smaller, something you can't even see. And it's a threat they fight every single day. The real threat is the unseen enemy. We're talking about microscopic contaminants and, of course, the potential for human error. It's a constant, high-stakes battle where the enemy is invisible and the margin for error is absolutely zero. Okay, so how do you fight an enemy you can't even see? Well, you don't start with concrete walls. You start by building a fortress of rules. And no, this isn't a physical building. It's a powerful, meticulously designed framework that acts as the absolute first line of defense. And at the very heart of this framework is something called cGMP, or Current Good Manufacturing Practices. Now, that little C for current, that's probably the most important part. It means these rules are never just sitting still. They're a living document, always evolving to include the latest science and tech. The goalposts for safety are always moving forward. And this isn't just happening in one country. Think of agencies like the FDA in the US, the EMA in Europe, and the MA in the UK as these global guardians of quality. They all work together to make sure that no matter where your medicine is made, it follows the exact same incredibly high standards. It's a unified, worldwide promise to keep us all safe. But rules on paper are one thing. To actually bring them to life, you need the right tools. And that brings us to the next layer of our fortress: a whole world of specialized, high-tech systems designed to keep everything completely sterile. This is the hardware of hygiene. Inside one of these facilities, every single system is put into one of two buckets. You've got process systems, that's the equipment that actually touches the medicine. Think mixing vats, pipes, that sort of thing. Then you have non-process systems, basically everything else that just keeps the building running. And that difference is crucial because anything in that first group is held to a standard of purity that is just almost unbelievable. Just how pure are we talking? Well, let's start with the water. You can't just turn on the tap. Nope. Manufacturers use something called water for injection, or WFI. This is water that's been purified to an insane degree, stripped of pretty much every mineral, ion, and microbe. It's purer than any water you've ever come across, and it's one of the most vital ingredients they use. And the same idea applies to steam. The steam that heats the building, it's full of rust and boiler chemicals. But for sterilizing the equipment that touches the medicine, you need something totally different: clean steam. This is pure vapor, made from that WFI we just talked about, with absolutely no impurities. It's the ultimate sterilizing weapon. So how on earth do you clean the inside of all this complex machinery between different batches of medicine? You use a clean-in-place, or CIP system. The best way to think about it is like a robotic cleaning crew that lives inside the pipes. It's all automated and super precise, which guarantees a perfect, identical clean every single time. It just eliminates the risk of human error or any cross-contamination. So the fortress has been designed with these intense rules and built with amazing high-tech systems. But the job isn't over, not by a long shot. In fact, it's really just beginning. Now comes the relentless, never-ending job of keeping that fortress strong through constant testing, maintenance, and control. Before a single piece of equipment is ever used, it has to pass this really tough four-step qualification. It's like a chain of proof. First, design qualification proves the idea on paper is solid. Then, installation qualification proves it was built and installed exactly how it was designed. Next, operational qualification proves it actually runs correctly. And finally, performance qualification proves it can do its job perfectly and consistently, over and over again. It's a mountain of documented proof before you even start. And this level of care extends to maintenance, which really falls into three buckets. The most basic is corrective. Something breaks, you fix it. A little better is preventive, which is based on a schedule, like changing an air filter every 3 months, whether it looks dirty or not. But the real goal is predictive maintenance, using data like vibration analysis to predict a failure is coming and fix it right before it happens. That gives you maximum efficiency without ever risking safety. The level of control here is just staggering. It's so strict that you can't change anything, not a single part, not one line of software code, without a formal change management process. Every single potential change has to be proposed, reviewed by a team of experts, approved, and then meticulously documented. It's all to make sure that no single unauthorized change can ever mess up the integrity of the whole system. So that brings us to the final and, honestly, the most important layer of defense. You can have the best rules in the world and the most advanced machines, but the ultimate failsafe? It's always the highly trained, disciplined people working inside the fortress. For instance, when a technician needs to work on a machine, they use a procedure called lockout tagout, or LOTO. It's actually beautifully simple. They put their own physical lock on the power switch. That makes it literally impossible for anyone else to accidentally turn the machine on. It's a low-tech but incredibly powerful procedure that saves lives. And for any kind of high-risk job, a permit to work is required. Now, this is way more than a checklist. It's a formal safety contract. It spells out exactly who will do the work, what precautions are needed, and who's responsible. It's a signed agreement that forces everyone to stop and think before they start a potentially dangerous job. And underpinning everything that people do is this one powerful mantra: if it wasn't documented, it didn't happen. In this world, if you do something but there's no record of it, it's like you never did it at all. Proof is everything. And the rules for this documentation, they're all about total transparency and permanence. Every entry has to be clear, written in indelible ink. You can't erase anything. Mistakes get a single line through them with your initials and the date, so there's a permanent record of the change. This isn't just paperwork. It's a legal, historical record that could be audited years down the road. So, the next time you open a bottle of medicine, just remember this invisible fortress. That simple little product you trust is the result of this entire ecosystem of rules, technology, and dedicated people, all working together to make sure it's perfectly safe and effective for you. Which kind of leaves us with one last thought. Could you work in a place with that level of accountability? A world where every single thing you do, no matter how small, requires documented proof and your personal signature? It's an extraordinary level of precision, and it's what keeps all of us safe.
Vinod Nair's podcast.